Hello students, welcome to this session of ISRO where we are discussing every subject one after another in every week, and here today we are to discuss the subject of algorithm, okay, subject of algorithm. Now here the idea is of this session, YouTube session, is to make you comfortable with the pattern of the ISRO. And I think previous to me, all the other faculties have already mentioned that how you have to prepare for this ISRO examination, what should be the focus, and many times it has been repeated. I'll also repeat one more time that your gate questions are basically important for this ISRO series. Now here we are dealing with algorithm subject, and the syllabus part here is you can see that tree and graph traversal, connected component, spanning tree shortest path, hashing, sorting, searching, design technique, greedy, dynamic, and divide and conquer. Okay, so plus you can say here which is by default it comes in algorithm is asymptotic notations and analysis. So here it is not mentioned, but asymptotic notations and the analysis. So preparation strategy and all I will not say again, because more or less you have heard this thing many times. I directly come to this question section here, syllabus. I'll just say the weightage over here, that throughout the year this is the complete big table, and throughout the year in 7, 8, 9, 11, 13, 14, 15, 16, 17, 2 papers, 18 and 20, how many questions are asked from the algorithm. You can see here the total here in this case is coming around 45 questions, and the last time in 2020 there are 6 questions were asked from the algorithm. So you can see that larger weightage, no, not a very large weightage, because there are some numbers like 121, 128, 104 questions. On an average you can say like number like 38, 50, 34, 35, 73. 75 is also very large weightage, which is from the data structure. So not a very you can say that you will not find too many questions from this particular topic, which is algorithm. That is what analysis is saying. But the main thing and the rule for competitive examination is cover entire part, cover everything. This is one analysis that I am presenting to you based on this 2020 analysis, and here you can see that there are data structure is 10%, database management 5%, digital logic 9%, operating system 13%, software 6%, theory of computation 8%, and this algorithm is around 9% of the question is asked from this particular topic. Sometime analysis help us to understand the distribution of the question, and we can target that particular part, but you can see that there is a organization is 15%, and here in this case is operating system is 13%. Like one overall idea you will get that how the paper will be structured here in this case. Now I will not waste any other time, and will directly come up here in this case is problem solving, and I pick recent year to I tried to include as many as year possible, and we are going to solve the problems, and at the same time you can also give answers, and you can do a little bit of practice. So the whole idea is to make the session useful for you, and that can be only done by solving more and more problems. So no theoretical aspect over here. So here what is the complexity of the following code? Sum is 0, and I is equal to 1, I less than equal to n, I multiplied by 2, j1, j less than n, j plus 1. Which of the following is not a valid string? A very unusual type of the statement, which of the following is not a valid one? So here this is the for loop, but here in this case is I is multiplied by 2, and when I is always multiplied by 2, we know this template, right? We know this template, that if I is getting multiplied by 2, then we know that this loop is going to run for log of base 2n time, because you can say every time I is getting doubled, power of 2, okay. So power of 2, so in this case it will take log n time to cover, and this loop is very straightforward, a nested loop, and it will take this n. There is a nesting of the loop, and this is taking log n and n10. So here the answer should be basically theta of n log n. Okay, this should be the answer. You can write it also as order of n log n here in this case. So the answers are in order form, but order is what? Order is the symbol for less than or equal to. Order is the symbol for the less than or equal to. So here in this case is order is a symbol for less than or equal to. So in this case order of n square, n log n is a lesser function than n square. Yes, it's a valid one. Order of n equal function, n log n is a equal function. Yes, it is a valid one. N log n multiplied by log n and log n square, that is also valid one, because order is there, theta is not there, order. But for order we have less than or equal to, so n log n is less than n square, true statement, and n log n is less than or equal to n log n, true statement. N log n is less than or equal to n log n multiplied by log n, that is also true. What is not valid here in this case is order of n. The answer for this question is not about holding it up, but not valid string, which is not a great statement, but interpretation can be only this, that not correct, and here answer in this case is C is the answer for this question. The first question, this answer is in this case is C. Okay. Let's move to the next question over here. Now, the Huffman tree is constructed for the following data A, B, C, D, E with the frequency 0.17, 0.11, 0.24, 0.33 and 0.15 respectively. This code is decoded as this particular code 100000110 is decoded as. Now Huffman coding is an application of binary tree with minimum weighted external path length. So this is an application of what? Binary tree with minimum weighted external path length. Minimum weighted external path length. Okay. So what is the idea? And I really find very amazing that student do not they search for a pattern to construct it. Idea here in this case is minimum weighted external path length will be only created when you select two minimum frequency, two minimum numbers, two minimum occurrences, and you try to merge it. So here in this, if you go here 0.17, 0.11, 0.24, 0.33, 0.5, two minimum here in this case is 0.11, like here 0.11, this one, and here in this case is 0.15. Convention says that you make the left one as a lesser value and right one as a greater value. So if I do this thing, then the combined frequency will be 0.1, 0.26 here in this cases. Now, so my initial array was this, where I got 0.11 and 0.15 is the minimum value, and I merge it and I get 0.26. Now you put it back, you put this one back. So if you put this one back here, 0.11 and 0.15, in this case you will get 0.17, then you get 0.24, then you will get, okay, let me write 0.26, this is sorting I have done, and 0.33, this. So this is the idea here, that you have to put it back, and again you need to select two minimum. So here in this cases, again if you select two minimum, then the two minimum is 0.17 and 0.24, and that will be in this case is 0.41. So here 0.41, and in this case is 0.33 will come. So now here I can say 0.17, this is the message, and 0.24, 0.24, that will be combined and they will become 0.41 here in this. Okay, now what is the, after this what will be the array here in this cases? I am going in a bit detail here because I have found that after explaining many times, still I find that confusion still remains here. So I am just taking some time for this particular question. So first two minimum was 11 and 15. So I just add this, then 1 7 and 2 4, that is 4 1 here in this cases. Next here I'll just say here one more time that what is left here in this case is 0.26, 0.33 and 0.41 this. So now definitely here in this case is 0.33 will be combined here in this case with the 20, this 0.26, and in this case it will become 9 and 3 into 0.59, 0.59, and then finally this and this will be combined, and that will become here 1. Now we try to maintain left and right combination, but if it is not possible, then we'll just simply lesser value will assign the value 0 and greater value will assign the value 1, 0 and then 1. Lesser value 0.260 and then 1. Here it here this is the 1 and this will be 0 here. Now 0.11 is the A, 0.11 is for the code here in this case is B, 0.11 is for B, 0.15 is the last one, that is for E, 0.33 is the second last one, which is D, 0.17 is for the first one, which is A, and 0.24 is the third one, AB, and that is equal to C here. So now we are ready with the code here in this cases. I can write the code for A is 0 0, A is equal to 0 0, B is, for B the code is what, 1 0 0, 1 0 0, for C the code is 0 1, 0 1, and for D the code is 1 1, 1 1, and for E the code is 1 0 1. For E the code is 1 0 and 1. Okay, so now 1 0 0 here, this is the B, then definitely this is A, then 0 1 is matching here in this cases, so this is 0 1 in this case is C, and then 1 0 1 is E. B A C E, answer for this question is A, B A C E, B A C E is the answer for this particular question. A is the answer for this particular question. So if I can see any response over here, so no response till now. Anyway, you can say the answer over here if you are solving with me in this case. This question belongs to greedy method, and in greedy method we have optimal merge pattern, and the second application in this case is the Huffman code, where we have to be carefully construct the tree. The idea for the construction of the tree is that you pick up the two messages with the minimum frequency and then merge it. When you merge it, it will create a new frequency, just adding it up. Then among the given set, like here in this cases, after merging it becomes 0.17, 0.24, 0.26, 0.33. After doing this, then also you have to do the same thing, pick up the two frequency with the minimum one and then merge it. It is not about that randomly merging one with another. You have to use this 0.26, no, it is not the case here. Okay, so that is the idea for this particular question. Okay, so A is the answer for this. Now, next question still from 2020. If array A contains the item this 10, 4, 7, 23, 67, 12 and 5 in that order, what will be the resultant array after third pass of insertion sort? So now here the question is about insertion sort, and sorting is one of the topic where you have to be really comfortable regarding this topic, because once you are in this insertion, there are many aspects are there regarding this sorting, and you have to be really feel very comfortable around this. So let me write the number 10, 4, 7, 23, 67, 12 and 5. Insertion sort, it begins with the second element. From here 4 I need to insert, because 10 single element is always sorted. So 4 I need to insert in the correct place. The correct place is what? Before 10. So it will now become 4, 10, 7, 23, 67, 12 and 5. This is the first pass. Second pass, I try to insert 7 in this sorted array. Now look at here, these two elements are now sorted. So 7 I try to insert. What is the correct position? After 4 and before 10. So it will become 4, 7, 10, 4, 7, 10, then 23, then 67, then 12, and then 5. This is the correct after second pass over here. So 4, 7, 10, 23, 67, 12 and 5. This is after second pass. Now third pass if I run, then 23 to be inserted, and 23 here in this case is compare with 10, 23 is a greater value. So you don't need to, because this part is already sorted, we don't need to again check for 4 and 7, because I've already find an element which is basically 23 is greater, 20 is the greatest element. So no change. So answer is what? 4, 7, 10, 23, 4, 7, 10, 23, 67, 12 and 5. Answer for this is B is the answer for this question. And just a simple question related with your insertion short over here. Simple question for the insertion short. Passes, third pass, insertion short. Okay. So that is the answer, the B is the answer for this particular question. Okay. So great, let's proceed here in this cases. Next question. Okay, now this question is again 2020. Because what happens here that you have all the year papers, but the main thing is that the recent year have more impact. We generally student ask that how will be the paper, or can we guess the paper. Generally we just see by seeing the trend. But what I observe here is that because gradually they increase the level. So the recent year paper in any competitive examination, the recent year paper will have more impact on this year paper rather than let's say 10 year back or 15 year back. Okay. So the recent year paper will set the trend, and that we need to follow. Master theorem, here in this case is master theorem, assume that the sub problems are unequal size, can be used if the sub problems are of equal size, cannot be used for divide and conquer algorithm, cannot be used for asymptotic complexity analysis. This is very simple one question. And the master theorem is what is the idea of the master theorem? So it is about the recurrence relation Tn, and it is A times T n by B, okay, plus f of n. This is the master theorem where base the equation for the master theorem here. Now here there are, what is the meaning here in this case is that and then we have cases. I will not write the cases here, but these are the thing. So here master theorem is about is having a sub problem, okay, of size n by b, of size n by b, a sub problem. There are a sub problem of size n by b. The unequal size, no, it doesn't assume that it assumes an unequal size here. They assume that there are a sub problems as n by b, means there is an equal size of the problem. Each problem is of size n by b. Cannot be used for divide and conquer, that is also false. Cannot be used for computing the time complexity. So case 1, case 2, case 3 is for the time complexity only. So here D is also wrong here. So now the answer is can be used if the sub problem is of equal size. What is that size? This is the sub problem size, that n by b, and a sub problem of size, each is of size of n by b. So that is the master theorem, and answer here in this case is B is the answer for this particular question. Okay. So that is the about master theorem. Okay. Okay. Let's move to the next question over here. The time complexity of computing transitive closure of a binary relation on a set of n element is known to be, okay. Okay, all are in order, but be careful with the order notation, because order is less than or equal to. So any greater value will also will be applicable here in this case. So what is a transitive closure? So transitive closure is given a relation like here 1 to 2 and 2 to 3. Suppose this relation is given to you, okay, and suppose 1 to 3. suppose this relation is given to transitive closure is closure means we need to find transitive closure means here in this case is all such pair we need to find out where A is related with B and B is related with A, that implies B is related with C, then A is also related with C. This is we need to find, and we need to find all such pair, like here 1 is related with 2, 2 is related with 3. So this is also 1 is also related here in this case is 3. This is the transitive closure pair that will come. So closure means here in this case is that you apply this thing many times, many other times you apply, and in this case you will get here 1 3 is already been added over here, so nothing nothing new we are getting here in this cases. Let me add here 3 is related with 4, suppose I will say that 3 is related with 4, suppose for example 3 is related with 4. So now see 1 is related with 2, 2 is related with 3, 3 is related with 4. So 1 is related with 2, 1 3, 1 3 and 1 is related with 3. Now after adding this pair, before I cannot say that 1 is related with 4, but after adding this thing 1 related with 3, 3 related with 4, so I will also add here in this cases 1 4 also I will add here. Understand 1 related with 3, 3 related with 4, so 1 4 is also there. 2 related with 3, 2 related with 4, so 2 4 is also there. So I need to find every such pair where A related with B, B related with C, and that relationship will hold in this case. Now understand that this is what is the algorithm for it, it will find out in this case, that is called Floyd-Warshall's algorithm. Floyd-Warshall's algorithm. And here the idea here in this case is the relationship is maintained as a matrix form, matrix. Okay. So here 1 2 3 4 is there, in that case we will create a matrix 1 2 3 4 and 1 2 and 3 and then 4. Okay. And we have seen that that 1 is related, what was the relation? 1 is related with 2 and 2 is related with 3. And what we have seen, 3 is related with, this is our relation actually, and this is R, 3 is related with 4. So in this case is 1 2 is 1 1 2 like this matrix we create. Just I will just say, I will not complete this one, I will just say how it does complete here in this case. Now 1 is related with 2, so this will be 1, 2 is related with 3, so this will be 1, and 3 is related with 4, so this will be 1, rest all the entry will be 0. Okay. Now this computation is like the all pair shortest path, all pair shortest path. Now all pair shortest path. Now here in this case everyone, one is the value of B, A is related with B, B is related with, so 1 is value of B, then we will go for 2 is the value of B, 3 is the value of B and 4 is the value of B. For every intermediate in this transitive relation we will use as an intermediate vertex and we will fill this matrix. So here 4 possibilities for this situation, A related with B and B related with C, B related with C. So for B value there are 4 possibilities are there, because there are 4 different vertex are there. Means 1 can go to 1 can be the middle vertex, 2 can be the middle vertex, 3 can be middle vertex, 4. So now this is n square computation, and this n square computation will be done for every value of B. What is the choice for B? 4. So 16 calculation, and 16 into 4, that is 64. So total here number of time we need to compute is 64, that is nothing but 4 to the power of 3, and generalization is n to the power of 3, n cube. So here answer for this particular question is D is the answer, that the transitive closure is computed based on the Floyd-Warshall's algorithm, and this can be done in order of n cube time. Okay, order of n cube time. In this case answer for this particular question is D is the answer for this. Moving to the next problem here. Next problem is from hashing. Okay, the next problem here in this case is from hashing. So see this question that it is from ISRO 2018 and it is very old GATE 1989 question is also there. 1989 question is also. Okay. So hashing, new topic. Let's read this one. A hash table with 10 buckets with 1 slot per bucket is depicted in the figure. The symbol S1 and S7 are initially entered using hashing function with a linear probing. Linear probing is one of the collision resolution technique. So what is this? Collision resolution technique. Collision resolution, linear probing. It says the maximum number of comparison needed in searching an element that is not present. Searching an element that is not present. How many comparison you need for searching an element that is not present over here? So here linear probing means what? Linear probing search the next location. Next location. So here in this cases I can go for next, like here I can go not present, it can be 0 also, like if the mapping is done to 2. It can be 2 also, 6, S5 and the next slot is empty, not present. It can be 3 also, S4, S2 and the next slot comparison. Empty is there but exactly nothing is empty. In real world nothing is empty, some value will be there. But the maximum number of comparison will occur when the slot is made not finding, understand. So it will compare with S6, then it will compare with S3, then it will wrap around, come to the beginning, compare with S7, compare with S1 and then finally compare with the 2 slot and it find empty and it not there. So 1, 2, 3, 4 and then 5. So here in this cases the maximum number of comparison needed here in this case is 5. There are total 5 comparison needed over here, maximum. So that is the answer for this question. There are 5 comparison needed. Okay, so that is the question for hashing and again this is taken from the GATE 1989. Let's move to the next one. Now, of the following sorting algorithm, which has the running time least dependent on initial ordering of this input? Okay. So now again a very understanding of sorting algorithm. Understanding of the sorting algorithm is required. Okay. That among this, which one is least dependent upon the initial ordering of the input? Means there is initial ordering means is it sorted, then complexity will be different, unsorted, then complexity will be different, or partially sorted, then maybe it will perform better. This can also be the initial ordering, partially sorted. Right friends, so here what about the insertion sort? The best case for the insertion sort is when it is sorted. Best case. Best case is what? In this case is n. Best case complexity here in this case is, it can say for insertion sort is omega of n and worst case here is order of n square. So it depends. Selection sort also in this case is depends upon the initial ordering and in this case is n square here in this case. A quick shot also worst case here in this case is order of n square. Here also selection shot order of n square. Now here you will identify that merge shot here in this case is merge shot is having same complexity, theta of what? In this case is n log n. Okay. So here in this particular problem least dependent upon, because least dependent upon the sorting algorithm, if you compare with complexity here in this case is selection sort and the merge shot is having same complexity order of n square and n log n for all the cases, but here I think the most probable answer in this case is n log n, because whether it is sorted or unsorted, okay, sorted or unsorted, here in this cases it is taking same time, in this case is n log n. So here we will go with in this case is A, but C I can also say that This can also be, create some doubt in your mind. What about the selection shot? Because we know that in all cases it is taking the same time, that is n square. So this situation will happen with the ISRO question. It is very common that they are really, sometimes some questions tend to be confusing. We will go merge shot, but selection shot is not, we cannot deny that entirely over here. Okay. Next question is given a sorted list of size m and n respectively, the number of comparison needed, the worst case by the merge sort algorithm. Okay, number of comparison needed for merge sort. Basically this question should be by merge algorithm, not the sort algorithm. Merging operation. So how the merging operation is done? In this case, is suppose this is 1, 3 and 5, and suppose this is 2, 4 and 6. 2, 4 and 6, 2, 4 and 6. This is the I and this is the J. How merging is done, and see the number of comparison. And what we do, we put them in the sorted list. This 2, 3, 4, 5 and then 6. So 1 is compared with 2, this is the number of comparison. 1 is compared, this is the worst case scenario. 1 is compared with 2, 1 is lesser, 1 is moved, and next pointer is 3. 2 is compared with 3, 3 is compared with 2, there is another comparison. 2 is lesser, so next pointer, next 2. Now 3 is compared with 4, 3 and 4s are compared, this is another comparison. 3 is lesser, 3 will move over here, the next point. 5 is compared with 4, 5 is compared with 4, 4 is lesser, so 4 will put over here the next pointer. 5 is compared with 6 here, 5 is compared with 6. This is the worst case scenario, 5 will be here and only one element remains, so it will come over here, that is 6. Now this is the merging. Now here you can see that there is a 3 element and 3 element, and the number of comparison required, in this case I can say m plus n minus 1. This formula is for worst cases m plus n minus 1. So here D is the answer for this question, that m plus n minus 1 comparison required. Now this is not the case that only for this element. Suppose it is 1 and in this case is suppose it is 10, and here there are many elements are there, 2, 5, 6 and 7. Then also 1 is compared with 2, 1 is compared with 2, then the final array will consist of all the elements, so 1, 1 is compared with 2, so 1. This now here, this now straight away 10 will be compared with 2, 2 will be here, 10 will be compared with 4, 4 will be here, 10 is compared with 5, 5 will be here. See, this is the largest element, it will be compared by every, it will be keep on comparing with every element in this case. So 10 compared with 5, then 10 compared with 6, 6 will be here, 10 compared with 7, and in this case 7 will be here, and finally 10 will be here. So see, total number of element is 7 and 6 comparison should be there, 1, 2, 3, 4, 5 and 6. Again the answer is what? M plus n minus 1. This is the answer for this question, and here I will say that m plus n minus 1. Great. So let us move to the next part over here, next question over here. Now which of the following is an application of BFS search, breadth first search? Finding the diameter of the graph, finding the graph is bipartite, and both A and B. Okay, this is a knowledge based question, you know it or you do not know it. Answer is that B, that finding the diameter of the graph and finding whether the graph is bipartite or not. Bipartite is making two groupings or two partitions, so that all the edges from one partition to another partition and no edges is from in the same partition. Now, I have done this, I have just note down some application where you can remember them, like finding the diameter of the graph, finding the graph is bipartite or not, And then peer-to-peer network, shortest path and minimum spanning tree for the unweighted graph. BFS is shortest path and MST both. Social networking website, crawlers in the search engine, GPS navigation system, broadcasting in the network, garbage collection, cycle detection in the undirected graph. Fold Ferguson is one of the networking algorithm, path finding and finding all the nodes within the connected component. Now this is, I have just summarized over here so that you can now here can see this one. Okay, good. So here okay, no issue. So this is the application of the BFS. If any other question comes regarding this BFS application, you can refer this particular set here. Great. Next. Now slowly moving to the next year question, the recurrence relation that arises in the complexity of the binary. This is simple, binary search. So how does binary search perform? Binary search is performed on the sorted array. In sorted array, we perform the binary search. Sorted array, we perform the binary search. And how we do? We just divide the array into the two part here. Two part. How we divide it? By comparing the middle element. So if you want to bound the recurrence relation, then T of n will become what? T of what? Sub problem n by 2. And by what? By comparison, single comparison that may take some constant amount of the time, which is in this case maybe k. So the best answer, the correct answer is T of n is equal to T of n by 2 plus k, where k is a constant value. Okay. Next is, which of the following in place sorting algorithm required minimum number of swap operation? Minimum number of swapping is needed. Swap required. Insertion, quick, heap sort and the selection sort. Now here in this cases, and I will say that swap required in worst case. This is again a sort of incomplete. We need to say in worst case. In worst case, number of swapping is required here in this case. So answer is selection sort, and reason here in this case is that what is the idea of the selection sort is that what we do in the selection sort is we try to find index of smallest element and replace it and swap, exchange and swap with first position. So we try to, like index of 1 you find the index. So for I j is equal to 1 to n minus 1, smallest we assume that this is the smallest one, and j plus 1 to n, we just to find the index of the smallest element. So in this case we will say that 4 is compared here, in this case is 8, so it is index will be updated to 4. Then it go to 6, no, 6 is not less than 4, so no updation. 9, no updation. But when it comes to 2, then 2 is a lesser value than 4. Then in this particular case it is index is updated to the value 2. Then it comes to 3 and index will be not updated. Then it will come to the value 1, and in this particular case index will be updated. Okay. So what is the idea here? And look at this, j plus 1 to n. For this location j plus 1 will become this, and this to n you find just the smallest index, and then you come out of the loop, this statement exchange. You come out of the inner loop and then you perform the swap operation. So we are not swapping here in this case is one after another. What we are doing, we are just in a loop we are finding index of the smallest element and exchange with the first position. So this swapping is outside of the inner loop. This is outside of inner loop, and that means in the worst case, okay, in the worst case, the number of swapping will be in this case is maximum. Worst case, order of n. Maximum swapping in this case is order of n. You can say theta also. So minimum number of swap here in this case is in the selection sort over here. Okay, in the worst case. So that is the whole idea of basically of the selection shot here. One of the very interesting question, but it is from the binary search tree. Okay, maybe some misclassification happens. A BST, a binary search tree used to locate number 43. Which of the following cannot be a probe sequence is not possible? Which of the following probe sequence is not possible? So suppose here in this cases we are searching for 43, 63 where you will go lesser value. You find 52. What? Again lesser value 14. 14 you go to the greater value, that is 17. 17 you go to the greater value 40, and 40 you get finally 43. Now is it the correct BST, binary search tree? Is it the correct binary search tree that every element here is lesser than 60, every element will be lesser than 52, every element is greater than this? Is a correct probe sequence? B. So 10, you want a 43, that means you go to 65, which is a greater value, nice. Then you go to the lesser value, why? Because 43 you are searching, so 31 you find, fine. Then you want a greater value, so you go to the 48, fine. Then you find a lesser value, so you go to the 37, but it is greater than 31, so fine. And then you find 43. Is it the correct one here in this case? So this also seems correct here. All correct. C. Then you say what is wrong? What is wrong in this? Which one is wrong? 61. Then what where you will go? Lesser value 61. Lesser. Again lesser 52. Yes, lesser. Again lesser 14. Fine, not possible. Then greater value 41. Fine, and then 43. So this is also correct. Look at this 17. Look at this D option. Should I draw here? Okay, and this space I reserve it for this. Look at it. 17. Not possible. So we know that answer in this case is what? Answer here in this case is D only. Okay, let me just okay, 17. 17. So let's say 17. Then what? Greater value 77. Okay. Then lesser value 27. Okay, greater. Till now it is a good binary BST. Then what? Greater value. Then it comes 66. Fine, no issue. Then you encounter here in this case is lesser value 18. Now this is a violation. See, 27, the 18, number 18 is in right side of the 27. But right side, if you take all the values that encounter here should be greater than 27, and where it is in the right side 18. So that is the wrong answer. This is wrong, and D is the answer for this particular question. Okay, some misclassification happens here in this cases. Okay, so let's move on. Next question is, a sorting technique is called stable. If it takes log n, again it's a gate question, again gate 99 question. So again another question which is from directly here. No, it is not the case. Divide and conquer technique, no, it is not the case. Relative ordering of the non-distinct element is maintained. This is the answer for this. That suppose there are two 42, 42 and then 6 and then 42, then 2 and then 1, and then you perform the sorting. Okay. Now answer that you will get will be, we know that it will be 1 sorting, after sorting. What will happen? If I sort this, to perform sorting here in this cases. If you perform the sorting, then it will be 1, 2, 6, 42 and 42. Now, did you change the relative ordering of the 42? How I'll identify? So suppose this is 42A and this is 42B. If the sorting preserve this ordering, that this is A and this is B, it is very important concept, that if the sorting preserve 42A and 42B, then we call it as a stable one. Okay. But if somehow it is 1, 2, 6 and it become 42B and 42A, okay, then this sorting algorithm is not able to maintain the relative ordering, and in this case it will become the unstable one. In this case, unstable it will become. So stable and unstable is about the relative ordering. It takes n space, no. So answer here in this case is C is the answer for this question. C is the answer for this particular question, maintaining the relative ordering over here. Okay. So when you have 42A and 42B in the original order, after the sorting also you maintain 42A and 42B. This application here in this case is in the database management system. In DBMS, you sort the database on a multiple key value. So there this thing make the impact that whether it preserve the previous sorting value or not. So it is very important to have a algorithm to be stable. Some non-stable algorithms which is not stable, okay, not stable. So what is not stable here in this case is selection sort is not a stable algorithm, selection sort, it is not a stable algorithm. Your quick sort is also not stable. Your heap sort is also not a stable algorithm. Heap sort is also not a stable algorithm. So these are some non-stable algorithms. It's a probable question. Again, the complexity of the program here in this case is this loop running time. So it is running from n by 2 half of the way, and I is less than or equal to n. This is what it is running. So approximately or exactly here in this case is upper bound n minus n by 2 and then plus 1. Approximately it will run for n by 2 times, and we know that j is equal to j multiplied by 2 is having what impact over here. So here in this case is what is this? What is this? What is this in this case? This is log of n, log of base 2, starting from 1 and n. So this is n by 2 log n, and that is I can say order of n log n. See, order is having no problem. Here in this case is you can say n log n. Then the problem with order, and previous question they are having so many issues with this, that if it is n log n, then order of n square is also correct answer, and order of n square log n is also correct answer, and n log n is also correct answer, because it is less than or equal to. And in many questions you will find this situation where the answers are in order, and nowadays you won't find the question with order, because order is something which is less than, everything that is less than equal to. N log n is less than equal to n square is true, n log n is less than or equal to n square log n, that is also true, and n log n is less than or equal to n log n, that is also true. The answer is in this case is B, C, D. But most appropriate answer, if I say the tightest bound, but tightest bound is not n square, tightest upper bound is not n square log n. The tightest upper bound, tightest upper bound, tightest upper bound, this is also term tightest upper bound. Upper bound can be many different type, but the tightest upper bound will be n log n. This is the tightest upper bound here in this. Okay. So the tightest upper bound will come here in this case is n log n, but if you say very strictly speaking, this is B, C and D, all three are correct here in this cases. Yes, Nishu Kumar, you have said this answer as B, C and D, right? Good. So B, C, D all. Next question, consider the recurrence relation T of n is equal to T of n is equal to 2Tn minus 1, 2Tn minus 1, that is all. So if I just replace it 2 multiplied by 2, it will become what? Again 2Tn minus 1, so that will become this, that is 2 square Tn minus 2, and one more time you want 2 square, it will become 2 times n minus 3, and then it will become 2 cube Tn minus 3. Okay, so kth term will be what? Simple. Kth term will be, in this case is 2 to the power of k Tn minus k. What we want? N minus k reduced to the base condition. We want n minus k value to be what? Base condition, greater than 0. Okay, in this case is greater than 0, very greater than 0, so 1. So in this case it will be equal to 0 in that case. So n is equal to, in this case is k. So now it will become 2 to the power of k, this will become t0, and it will become k is equal to n 2 to the power of n, t0 is equal to 1. So that is multiplied by 1, so 2 to the power of n. Answer is B, that big O order, and fortunately again big O order, but all are lesser value, order of n, order of 1, order of log n. So again fortunately here in this case is the bigger one. So in this case is, yes, previous quotient, tightest upper bound will be this in this cases. So B is the answer for this particular quotient. So B is the answer here. 2t n root n by 2. I suppose that this will be the last question that we are discussing over here. 2t root n plus 1. So I will just say this space t of n is equal to 2t root n plus 1 here, and t1 is equal to 1. Again there is a small mistake maybe, but it should be t2 is equal to 1. For all root n question, we cannot take 1 as the base condition. I will tell you why. So let us do the replacement. Tn is equal to 2 times, let me replace root n. So what it will become, 2 times t, and it will become n to the power of half, that is root, and again half of it. So what it will become, n to the power 1 by 2 square, and then plus 1, and outside also there is a 1. Okay. So that will become 2 square t, n to the power 1 over 2 square plus 2 and then plus 1. In every time for the recurrence relation, never write 2 plus 1 equal to 3, because they are tending to form always a sequence, a GP series most of the time. Arithmetic series less number of time, but most of the time geometric progression. Now here 2 square, one more time, 2t n to the power 1 over 2 to the power of 3 plus 1, and outside there is a 2 and then 1. So that will become 2 to the power of 3. It is an important question, 2 to the power of 3 and t n to the power 1 over 2 to the power of 3 plus 2 square plus 2 and then plus 1. Now kth term will be what? 2 to the power of k t n over 1 over 2 to the power of k plus this is k minus 1, and up to here 2 square plus 2 plus 1. Okay, this part. Now the base condition reduction, so n over 1 over 2 to the power of k. Now here if I take the value 1, and if I take the 2 to the power of k both side, why the base condition is never 1? Because if I take the 1 to the power anything, it will be always 1. That is why this root quotient does not have a root base, in this case is 1, base value is never 1, rather than it is always remain as 2 in this case. So here look at here, this reduction over here, we are almost done, is equal to 2, and n is equal to 2 to the power of k. This you understand. So if I take log here, so log of base 2 n is equal to log of base 2 to the power of k, and in this case is 2 to the power of k is equal to log n. This is what we are getting. Now, so this series is there that I need to solve, this geometric series I need to solve, 1 plus 2 plus up to 2 to the power of k, and we know that 1, 2 to the power of what? K plus 1 minus 1 divided by 2 minus 1. What is the formula? A r to the power of n minus 1 divided by r minus 1. Okay. So we are done. This is 2 to the power k multiplied by 2 minus 1, and from this I can say 2 to the power k is log n, that is 2 times log of base 2n minus 1, that is equal to here. Again order, we have to be careful that order, and not a correct choice here. The tightest bound, again I am saying the answer is true. True in this case is log n, root n, and all are true, but again the tightest one in this case will be again log n. So answer is B, but not in order again. Answer is B, but not in case of order here in this case. So that is again the tightest will be in this case is or log n here in this case is n is equal to 2 to the power of k, and B is the correct answer for this. Okay, thank you for participating, Nishu, Mani, and okay, great, good response, nice. Okay, so now we are done here. Just products are there. There is a ACE online platform where there is a self-paced classes is there. Self-paced classes means you can, as per your convenience, you can access them, tablet and mobile both. We have this is one of the very important course, that is quick revision course. That in less number of hour you can complete the entire particular course. We have a previous year question series also, where you will find all the question discussed topic wise, and this is really help you in practice as well as getting the answer on a very instantly, and you can verify your answer over here. हिंदी में भी अवेलेबिलिटी है इसकी, और आप हिंदी कोर्स भी यहाँ पे परचेस कर सकते हैं, और this is GATE entire syllabus is also in Hindi for civil engineering, mechanical and electrical and computer science. Last but not the least, we have our this book, ISRO book, where topic wise and year wise questions are available over here. That will help in your preparation. Okay. So that is all from my side. I hope that this session, whatever amount you have spent, is fruitful, and you are able to solve question related with this, because ultimately we have to go in the examination and solve questions. That is the main thing. Concept clear, more understanding, application. Question should be answered correctly. That is the main thing. That is all from my side. Best of luck each one of you. Thank you very much.